Hello friends, in this video we are going to discuss the second program of your CGV Lab, that is create and rotate a triangle about the origin and a fixed point. Here we need to create one triangle and we have to rotate it using a fixed point, and that fixed point is going to be entered by the user. Now for rotating a particular triangle we are going to use a two-dimensional rotation matrix, which is given by, it is a 3 by 3 matrix which is given by cos theta minus sin theta 0, sin theta cos theta 0, 0 0 1, and already we have discussed about this 2D rotational matrix. Now we are going to implement this program using the concept of 2D rotational matrix. Now first of all we are going to specify the coordinates of a particular triangle. Here we are going to use a name for our triangle as house, because triangle is a built-in function. That's why we are going to use a name as house, and these are the three different vertices of this particular house. The first vertex is 100, 500, 300, second one 100, 100, 500, and third one is 1, 1, 1. Now after that we have declared two matrices. One is rotational matrix and second one is resulting matrix. Now what we have to do, we have to find out the rotational matrix, rotation matrix, and we have to multiply your house matrix with the rotation matrix to obtain this resulting matrix. First we will see how to create a rotation matrix. Now with the help of this rotational matrix we are going to create a new rotational matrix for our program. Now as I told you, the rotational matrix is given by cos theta minus sin theta 0, sin theta cos theta 0, 0 0 1. Now same values we are going to assign for our rotational matrix. Rotational mat 0 1 as minus sin theta, rotational matrix 0 2 as m, rotational matrix 1 0 as sin theta, rotational matrix 1 1 as cos theta, rotational matrix 1 2 as n, then rotational matrix 2 0 as 0, rotational matrix 2 1 as 0, rotational matrix 2 2 of 1. Next we need to multiply this rotational matrix with our original matrix or original points of a particular triangle. Now after that you just draw the original triangle here. For that you just use gl underscore line underscore loop function with three different vertices of a particular triangle. Okay, after drawing this triangle, next thing we need to rotate. Now for rotating we need to multiply our vertices with the rotational matrix. Now after multiplying, where the result is going to be stored in a result matrix. Hence for drawing a rotated house we are going to use a result array here. Result two-dimensional array we are going to use for drawing the rotated house, and again we are going to use gl underscore line underscore loop, and we are going to give the three vertices, that is resulting vertices after the rotation. Now in display you just call draw house. First it will draw the normal triangle, then you rotate it, call the rotate function, then finally you draw rotated house, call this function to display the rotated house. Now this theta is going to be specified by the user. Now that is going to be entered in your main function. Here you can see it will ask you to enter the rotation angle, that is theta 1, and then second value it is going to ask to enter a fixed point for rotation. They have told here to rotate it along a origin, means you have to use 0 0. You can use any other values also for rotating for a fixed point. Then you create a window, assign the window size, give the window title as geometric transformation sequence, and set that display function as display, and then glut main loop to display the particular window onto the screen. Now we will see how to compile this file and how to run it. Now to compile this file, we are going to use this command gcc expt2.cpp minus lgl minus lglut minus lgl. After that once you compile it, the next step, now you can see here there is an error